Hello, I'm gonna talk about designing a parking lot, which can be a bit of an unexpected side of system design interview, but it's a kind of a question you may get sometimes. So it doesn't have to be specifically a parking lot, it can be like any other like structure or system you encounter in real life. And on the first glance, it may even not have to do much with the software. So what do you do about this? So I will go over like some topics and see how can you approach this. So first of all would be clarifying questions and requirements. So then we're gonna go to parking lot description, which is like summarizes what we'll like choose and how do we like can suggest specific solution. Then we'll talk about data schemas for a change instead of high-level architecture for the software, because it's more important here to not just like a typical like web app, but more like what data we have, how we structure it. And sometimes interviewers may explicitly ask you to talk about this aspect. And then we'll also talk about indexes and cache as additional topics. So clarifying questions and requirements, there would be a lot. So is it a free or paid parking lot? Well, if it's like a free one, we probably don't really need to like design much. With a paid one, it's going to be a bit more components and pieces. And then we check in what is a software system for registration, payments in the lot, then what kind of vehicles are supported and their sizes, how many vehicles can be in the lot, how many lots do we have, do they all have like similar system and layouts, or layouts actually can be different, but like approach to how we like charge, for example, can be similar. What's the way to track how full is the lot, and how do we avoid charging vehicles that can't find a spot? And what are the payment methods we support? How do we enforce that payments are made? And then specifically, like, do we focus on data schemas and components architecture? That's why I foreshadow that we'll focus on data schemas. There can be a variety of parking lots out there. I'm gonna go with the following, but know that like it's just like one of options. Interviewer may like guide you or like ask you towards like a more like specific one. So there are like parking lots, for example, where you pay after you parked. You just enter like a license plate or your spot number. Alternatively, there are ones where you like enter through the gate, get a ticket, park, and then like pay for the ticket after you are ready to go. So we're gonna have parking garage with multiple floors and numbered spots. People park their car, motorcycle, one of the spots, go to their payment machine and enter the spot number and duration of parking, and which can be later extended. Also for convenience, there are light indicators which show either green depending on whether or not the spot is taken. And then dashboard is a parking lot entrance showing how many spots are free on each level. Seems pretty like typical what you would see on some like those real parking garages, and that's what you should aim for. Like basically, yeah, you probably don't know much about those like software systems which do like power parking lots, but what you know is like typical design of like how the system itself may look like. So you just need to identify what can be some pieces and like abstractions that you can use, and just like maybe suggest them to the interviewer, but also like don't forget to like ask a lot of clarifying questions. So then we'll focus on design data schemas and their relations, assuming the relation DB. We talk about additional topics like indexes and cache. So data schemas. So first of all, we'll have parking lot. We're gonna have some ID in case we like later like extend the system to multiple lots or like already have multiple. Some name or address. There may be like other, like maybe like some like coordinates of location. But we're gonna keep it short. Then there is a spot, has the most. So we have ID, some parking lot ID for like foreign key. size, location, maximum duration, some rates information. Then occupancy, it's for a spot ID, and reserved from to reserved until. It's a pretty like simple system. If you have like for example by license plate, you can have instead you would have abstraction of a car, which would have like probably just like license plate number or like vehicle in general, and then also reserved from reserved until for a given like vehicle like license plate. And then there is payment machine. There's ID, parking lot ID, and also location within this parking lot. Relations parking lot to spot one to many, parking lot to payment machine one to many, and spot to occupancy like one to one. And indexes, like we're typically gonna just have some IDs and combination of IDs. Like for example, for spot, we're gonna have ID, parking lot ID, and ID per last parking lot ID. All of them require like separate indexes. And for indexes, useful for query optimization if it's queried by specific fields, like when typically we'll query spots by index. Typically indexes by various kinds of ID and their combinations are added. Each combination requires separate index, and each multi-key index requires some order. Actually, I think going back to here, we can add indexes for like reserved from to reserved until, especially reserved until, to be able to easily query what's expired or about to expire. So indexes can be implemented using a hash map or a red-black tree, specifically for cases when we have indexes on timestamps and want to do some range queries. Those are like give a good combination of like update speed and also query speed, and some upper bound, lower bound. And usually the database engine itself would take care of index updates when the data is updated, which is a big advantage. Note that this advanced topic is the order of the trees. I think if you have like for example some ID plus like a red-black tree on time range index, you want a time range first, because otherwise you will have like a lot of this like small sub indexes for each ID, which are not gonna really give you like an advantage when doing a range query. For cache, it may be useful to have a cache in front of DB for frequent queries optimization. Since the data doesn't change often, adding the cache and some invalidation can be a good way to save resources and preserve high durability by the database. It can be useful for optimizing manual and automated queries to see which spots may be needing expiration expired some time ago. Cache can be done for each index, basically, or like a combination of indexes. And note that it may be only truly necessary if like indexes being there is not enough. So if the call volume is extremely high, because in modern databases indexes are pretty good. And like actually these stereotypes that hey, relational databases are not as fast, they're like much faster now. So thanks for watching. That's gonna be it for today.